Okay, so let's wrap this up. I'm going to maybe go over the physics layers a little bit more, just to reinforce it. So let's have a look at project settings. Physics. If you scroll down, you see something called the layer collision matrix. So this is very handy if you want to lighten the load for Unity for your computer. To instead of calculating collisions of everything with everything, you can actually restrict it somewhat. So, for example, this shows all the layers that we've created, and a kind of a triangle. It's half of the full array, because well, it goes both ways. Water with bullets and bullets with water. I mean, it's just one setting there. So that's why you see only half of the matrix. So let's say, what does it let us do? For example, look at the bullets column here. The vertical columns. It shows us which layers is it selected to interact with, and we can uncheck everything except for bullets. And what that would do is basically only objects on the layer bullets only collide with objects on the same layer. So this is a good setting to know about. Let's play with this. I'm going to run the game. And let's see, okay, our player has layer player, of course, so this is where it is. Let's uncheck player versus machinery. So now our turret no longer collides with the player. So I'm switching it on and off, and this action is deactivated. But also, when we deactivate this, what's happening is that we just fly through the turret assembly altogether, even though there's colliders on that. So if I check it back on, not only does the turret shoot at us, but also we have kind of properly collided with it and then flew through. Okay, so that kind of, I think that demonstrates what you can use the layers and layer collision matrix for. I have a couple of slides about this. Well, Raycast layer mask we covered. One interesting point maybe to make also is sometimes you have more than one camera in the scene. So let me do that at runtime. So I don't actually want to change this permanently. So I'm going to do this at runtime. I'm running now. Let me duplicate the main camera. Actually, I'll duplicate the main camera, and I'm gonna disable or remove the component simple camera follow, so that one of them follows the player and the other doesn't. So now, okay, I can see that one of the cameras is just stationary, and the reason why in game window we see only that stationary camera is because of its priority, so the depth here. So this main camera, this is the stationary one, they both have the same depth. So I'd like to increase the priority. I'll put this to 0. This is the main camera, actually, sorry, okay, apologies for that. Now I have two cameras in the scene. One is following the player, The other one is stationary. On the stationary cam I leave depth at -1. On the main camera I change the depth to 0. This means it's higher priority. So whether I put 0 or 1 there, I can put 1 there. Right now this is the main camera. But what else I can do is I'm gonna, every camera after it finishes drawing, this is the one, so I'm gonna, change the clear flags to don't clear on one of the cameras, and now I have something like really weird happening. So now I can see that I actually have two views combining. This is only rendered, has nothing to do with physics at this stage, but now I have kind of like an overlaying view from the cockpit, and another one which is external view. And the normal kind of culling operations based on depth are done as usual, so you do have things kind of behind, some objects behind other objects, but it kind of doesn't make sense anymore. But what you might want to use this for is if you, for example, want to use a separate camera for drawing your user interface. Like a lot of the time you will want to have a bit more control of the specifics of rendering your interface, and this actually helps a lot to separate it out into a separate camera and play those kind of games with depth and with clearing flags. So it's good to know about that. So for that also you would use you could use culling masks. So one of these cameras can have, for example, can only render UI, and so let's say it's change. I would only set it to culling masks including the UI layer, and the other camera I would say to everything except the UI. So a mixed mask that doesn't include the UI. Okay, so that's I just wanted to kind of drop that there, and let's see where we are. So one thing that is a little bit still a little bit rough is right now every frame we're shooting a bullet. This is a little bit extreme. So let's try to put in some kind of a timer. So let's see what's the kind of simplest way to put in a program in an interval, so that we don't shoot every frame. We just make sure that some time has passed before we can fire another bullet. It's actually a very simple approach. I'm going to just show you a very simple way to do it. I'll add a private float. Private float. Gun timer, and default value 0. What I'm going to try to do with this is imagine a counter that's going to be decremented with every frame by the amount of time that frame took to draw. So that's done very simply. Gun timer, gun timer. Minus equals, so that's decrementing, by time dot delta time. Obviously, if we start from 0 value, we're going to go into negative values, but that's not a problem. You know, it's a float, so float value can be negative. The computer doesn't care. So we are decrementing, and now what we want to do here is here we've gone through our stages of alerting the turret of the player, and then running the raycast, and then checking if the collider is the player. We're gonna add an additional conditional, like we're gonna make it a bit more refined. So we're gonna make this dependent on both the collider tag being player and gun timer being a negative value, so less than 0. Only if those two are fulfilled, and they both have to be fulfilled, so the collider tag of the raycast has to be player and the gun timer has to be less than 0, then we instantiate our bullet. But then what we do, and I'm gonna actually add a public variable, gun interval. That's a little bit extreme. And let's call it 1 second. So now, if we instantiate the bullet, what we're going to do with the timer is reset it. Gun timer equal gun interval. So, we shoot the bullet, we reset the timer up to 1 second. And that will be then decremented. And while this is positive, we're not going to be allowed to shoot bullets. That's it. That's the simplest possible way to do it. Not the only way, but that works. So let's try. Additionally, it gives us a chance to adjust that on the fly. Okay, so now ping, ping, ping. Okay, so great. And now let's change the interval to 0.5. Ping, 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 and 1/10 of a second. Okay, so we have some control over this now. Cool. Any questions about this part? I mean, this is a fairly simple approach, but maybe it's not intuitive. It uses the time delta time. This is going to be a fractional value, so it's going to be the fraction of a second that it took to since the last frame was drawn. If you remember, update is drawn every frame. And then this time delta time is going to be a value, like a very small value, like 100. Depends on what your frame rate is. So basically the inverse of that. If your frame rate is 200 frames per second, it's going to be 1/200th or 0.0005. Okay. Okay, let's make it a little bit more interesting with a little bit of sound. So now I don't have this covered in the slides, but I can add this later. What you need to have a little bit of sound in your game, and you probably played with this already, or if not, this is a chance to check it out. So first of all, to hear some sound in the game, you need to define where you're hearing from. So if you're the player, you would want to, because the sound in Unity can be quite complex. It can be a spatial sound, depending on how far you're from a sound source. You'd like it to be attenuated. Sometimes you have directional sound. In VR, it's very important to have like a very spatialized sound treatment. So for this, you need to have an audio listener element on the main camera. That's all that needs to be in the scene, only one of them. And then on the object that you want to have the sound come from, you add an audio source. So let me add that. and it's got a lot of options, maybe a bit overwhelming 3D sound options. At the moment, like, the default settings are okay for us, other than maybe the play on awake. We don't want the sound to be played by default, so we're gonna leave that. And another sound source we're gonna put on the player. So I'm gonna add a audio source on the player as well, and I'm gonna disable play on awake. Now I need some audio clips, so I'm going to just add this here externally. I didn't add this to the project, but I'm sure you can find some simple wave sound or OGG file. Let me just go into assets. I'm gonna create a folder audio effects, and I'm gonna add some very simple sounds. Let's say click. Okay, just a couple of short sounds. We're gonna be able to see what's going on. Okay, I'm gonna make this a bit louder. And for the turret, I'm gonna add a shooting sound, which is just like a click. Well, it's not going to be very exciting. Let's see what we got there. Yeah, it's just, I'm gonna, yeah, that's fine. For the player, I'm gonna add a slightly more interesting sound. That's gonna be when the bullet hits the player. Okay. So all that remains is to assign this now into the audio source. So okay, I've got this, and in code, we're going to want to trigger this when the player is hit by the bullet. So let's go to the player controller. If we remember, the collisions trigger the event both on the collider trigger and the object that collided with. So in this case, player is the object which has the rigid body, which is entering into the collider trigger area. So the collider trigger area is the one from the bullet. So what do we need? On trigger, enter. Also, we will need a variable, specifically private audio source. Yeah, and we need to assign this audio source, find it. So get component. Again, we need to specify the type, audio source. Remember, the get component method has a bit of a funny way of specifying the type. In triangle brackets, it doesn't actually have any input arguments. That's why it looks a little bit funny. But okay, in start we have assigned this, so that's okay. We're gonna do the same thing in the turret, because that's the one doing the shooting. So in start, we're gonna find the audio source, and I'm gonna copy it to be faster as well. So in turret controller, I am placing also a variable of type audio source. Okay, and now all that needs to happen is here, where I'm instantiating the bullet, audio source, play. Okay, and that's all you need to do. and in the player controller, that would be on the on trigger enter. If other collider, that's your game object, layer. So I'm going to use this layer now to specify that I'm using bullets. And layer is, let's see at the type of the layer variable, layer field, it's int, it's an integer. So that's a bit of a difference from using the tags, because you're referring to layers by numbers. So let's have a look. That's a quick lookup. Bullets are layer 11. Okay, so if this layer is equal to 11, audio source, play. Okay. So let's see how that works out for us. Well, we're not gonna get awards for sound design at this stage, but it demonstrates the okay, so that's a little bit of sound and excitement. Okay, we've covered quite a lot today. Any questions up till now? Or any bit that you feel you'd like more clarification? This is a good time to ask. So. Okay. Well, that's the point of us meeting here. So I can go more in depth in the parts which will give you some trouble. So out of these things, say we've covered today the collider triggers, so that should be fairly simple. We know how to use on trigger enter, on trigger exit. There's another one available, on trigger stay. The distinction between these ones, there is a little bit of a difference between them that you have to be aware of. Is on trigger enter gets triggered only the first time that the collider rigid body enters the collider trigger. Same for on trigger exit, it's only called once. So this one, you know. Okay. Is it possible that your layer matrix has been modified? I think, actually, I apologize. I think I had this part obscured. So let's just check if you have. Is your turret layer set to machinery, John? Okay, so that would potentially. Did it actually fix it? Because okay, it depends what you have in the project settings now. So this is the part that we have been playing with, and at the moment I have everything checked. So like the full computation is done between all the layers for all the colliders. So if you have something checked there, it might make a difference. But I don't think that would actually break your turret controller in this case. So hard to say off the top of my head. What else could be wrong? You said where we applied the layer masks. Is it working now? Okay, I suppose probably one of the more complicated things that we've done today is the layer masks. So for raycasting, and also raycast itself. So this is quite a long piece of code that I just pasted without maybe talking about it in too much detail, because when you use physics raycast, there's quite a lot of overloads. There's 15, so there's lots of versions of this method that allow you to specify different variants. So maybe let's have a look at some of them and see what's available. Okay, so this is the one that we used, which is the 15th overload. So it specifies the origin, the start of the raycast, the direction, the vector, which we specified as gun transform forward. Then we specify our output type variable raycast hit, called hit. We set up max infinity as a distance. Actually, this is something we can play with. We can reduce this distance and see if it breaks the turret. So let's do it really quickly. We'll just mess with this math infinity here. We'll make it. We'll reduce it to, let's say, 2. So 2 meters. In general, in Unity, the units correspond to meters, so that's when you start like working with more complex workflows, and also with physics. things are meant to be realistic, assuming that 1 unit is 1 meter in the game. So I've reduced in code the raycast extents, maximum raycast extents to 2 meters. Let's see, okay. It tracks us because it should track us, but now we're still within larger distance than 2 meters. We have to get actually closer. See that we have to actually be quite close to register the hit. Okay, so this was just to prove that we can, and this is a good game to play with all of the bits of code which you find a bit complex and unfriendly looking. I mean, yeah, this is a long line of code with lots of arguments, and then the next thing at the next lab test, I will ask you to change something. So this is where you need to focus your attention. Those bits where maybe things are beginning to look a little hairy. So what can we change, and what would that mean? So look at the individual parameters, infinity, and play with them and see what they mean. So in this case, what else can we play? The raycast mask. The raycast mask we specify and can modify even at runtime. So okay, my interval is a little bit small, so I'm gonna just make it every 2/10 of a second or 3/10. And raycast mask now, if I include the machinery in this, okay, for some reason water was in there. If I include machinery in this, I wonder if I actually run into some problem. Yes, you see what happened? The minute the gun nozzle intersects with the turret, what's happening is that the bullets are probably... Okay, I'm going to change to wireframe display and we'll see if we can actually see this. I'll go to the gun, the center of the gun, and I'm going to reduce the bullet prefabs. Bullet. I'm going to reduce the speed of the bullet to maybe 1 and see if we can see anything happening. That maybe doesn't... okay, that's not the best way to show it. What I did want to demonstrate is, in this case, if the intersection line of if the raycast, basically the ray starting from the center of the gun, now hits an incorrect layer, which is the actual machinery layer, then we stop shooting. Hostile turret, raycast mask, okay. Machinery is now included in the layer mask. Let's get closer to the turret, and it no longer shoots at us because you can see this little bit of the turret is intersecting and the raycast is being stopped by the wrong layer. So this is one of the reasons why we use layer masks. So I disable that layer and now everything is good. Okay. By the way, is there any more questions about for loops? Like, let's say the next lab test, if I would ask you to create a triple nested loop with some if statements in, Are you confident that you can DM me later if you still feel that this is giving you trouble? But a lot of people have struggled with the wall exercise, so I'm a bit concerned where that's coming from. Another bit which was, and I'm not sure if it's, I'd have to come back to you about that next week when I'll prepare maybe some more specific materials for that. Let's see. Okay, I think I can think of something worthwhile to test now. If you remember, we've made the turret animation independent of anything else in the scene. So now our hostile turret should be like a standalone prefab that we can use in a couple of places. So let's try something. Let's update. Let's make sure that our prefab is updated. And I'm going to remove, for the time being, I'm going to remove the city buildings. So let's go into the hostile city manager. And I'm gonna comment it, remember, /*. Save, okay. And what we're gonna do instead is instance a couple of more of those prefabs and see what happens. So I'm gonna put it here in the scene. I'm just gonna move it around. Let's say over here, and another one, right click, duplicate, and let's move it here. Each of them will come with their own collider zone. Okay, how does that look from the top? Yeah, okay, we managed. And let's see. The only thing is the prefab right now is I'm going to modify the prefab. Again, this is one example where the prefabs are very helpful, because now I'm just going into the prefab, opening it, change the gun interval to 0.1, save it. Okay, and have a okay, I'm still in the prefab view. Okay, now this is starting to be a little bit more interesting. Were you able to recreate this in your scene? I'm noticing a little bit of a problem here when we're actually right in line with the turret, and I think I know where this comes from. If I look at the player here, when you see the reference position of the player, the root actually is below the model, and when making the collider for the player, which I did as a box collider, I have adjusted it to the mesh while forgetting that this is not including the actual position. Okay, so this is how to fix this. If you keep an eye on what I'm doing here, I just selected Edit Collider, so I need to do it on the offline mode. Okay. The problem is, again, that the reference for the object is below the actual collider. So what's going to happen is that when we're aiming our raycast directly at this point, it's not going to collide with the car collider. So we need to fix that for sure. Just an example of a type of a bug that you might run into. Sometimes it's a combination of a couple of things, but this one would have been quite easy to miss. So what I'm doing is I'm clicking Edit Collider. This allows me to click on the gizmo which controls the collider's extents. I'm going to just extend it a little bit just to be sure, and that's good, and I save it, and I no longer have this problem. So let's test it. I'm moving up. Yep, it's now working quite well. Okay, so the next couple of steps, and that's something that I'd like you to actually think of at home and play with in your self-study time, is to well, we still have a little bit of time, so actually I'm gonna turn the tables a little bit, and I'm gonna ask you to, starting with this scene with the several turrets in it, I'd like you to create a health variable on the player. I haven't decided yet, Shashank, so let's see how it goes. We need to cover a little bit more material right now. It's we had this delay, so we lost time. Yeah, so it's going to be another lab test, also 5% of the course grade, and then the rest is going to be the final project. I will create a brief for you to focus on next week, but you can already start thinking more seriously about the final project, which basically I'm expecting a small game-like experience using the techniques that we've been learning. Using this modular city system, you can extend it or change it, or maybe only use parts of it. But it is up to your creativity to come up with something interesting, and also in the direction that you're interested about learning. So I mean, this is an opportunity for you to learn about the things that you find exciting. So if you're interested in shoot 'em up games, maybe move in the direction that we've been working up towards today. If you're maybe more into adventure games, well, maybe you'll need to wait until we cover a little bit more of pathfinding and maybe slightly more advanced AI concepts, but you already have some building blocks to start playing with. So this is the time to really jump in those sample scenes that we worked in before, play with them, get creative, see where you're going with it. And next week I'll give you a more definite brief, but you can already start preparing your ideas so that so that we can make the best out of it. Yeah, today I'd like you to now get started on this very small task there, which is I'd like you to maybe I'll write it down. Add a public health variable to the player, and with each bullet hit, decrement that value. And then if that value goes to 0, destroy the player. Okay, so go. Ask me questions. I'll try to assist you. If you want, you can DM me. I'm gonna stop the recording, so I think there's no need to record this. This is most of the material that I had ready for today, so try to extend it now.